Welcome back to Team Adams Teaching. We are working with special triangles today. We're using our angle sum theorem of triangles, that angles of a triangle add up to 180, and looking at some special triangles that will help us with these problems. So we're going to do a quick review when we classify triangles by their angle sizes. If you have a triangle where all the angles are acute, then it is an acute triangle. In order to be a right triangle, you only need one right angle. So as long as it has one right angle, it is a right triangle. And in order to be an obtuse angle, you only need one obtuse angle. Otherwise, it won't make a triangle. Can you imagine trying to draw a triangle, 3 sides only, with 2 right angles? That's not a triangle. Okay, same sort of thing happens with these. So right angles, obtuse angles, they're the only ones in those triangles, and that's okay. All right, and then we have classifying triangles by sides, and there are 3 types. There's scalene. Scalene means all the sides are different lengths. So maybe this side is 4 centimeters, and this is 5 centimeters, and this is 6 centimeters. But all the sides are different lengths. There's also the isosceles triangle, where you have a triangle where 2 sides have the same length. And in this one, if you want to show that 2 sides or 3 sides of a triangle, or even their angles are equal, you use these tick marks. In this, if it has 1 tick mark here and 1 tick mark here, that means that one is equal to that one. Over here, I could put on this one 1 tick mark there, but notice this one's not the same, so I have to use a different number there. And notice this one's different than those 2, so I'd have to use a different number of marks there. But if they are the exact same size, then they get the same number of tick marks there. And so isosceles, 2 equal sides. And these isosceles triangles have a pretty special feature. I'm going to draw this just a little bit bigger. Or a lot bigger. If this side is equal to this side, there's something special in that the angles across from it are exactly the same size as well. So this angle here and this angle here are going to be the exact same size if these 2 sides are equal. So maybe this side is 8 and this side is 8. Maybe this side down here is 10. When it comes to angles, if this angle here is 35 degrees, that means this angle here has to be 35 degrees as well. So the angles across from the equal sides are also equal. And well, that goes for equilateral triangles too. Equilateral triangle has 3 equal sides. So maybe this is 12 centimeters long. That makes this one 12 and this one 12. And again, we can show this by either with numbers, or we can put the tick marks through. On this case, let's say that one is equal to that one is equal to that one. Remember that angles across from equal sides are equal. Well, the same thing goes here. This angle has to be equal to that angle, has to be equal to that angle, since all the sides are the same. So we pretty much just have 3 equal angles here. And I'm going to show you what each size is in just a moment on our problem below. So equilateral, 3 equal length sides. Isosceles, 2 equal sides. And scalene, no equal sides. So we're going to jump down here to this one. We don't know how big this angle is. Maybe you do. But I don't know it yet. But I do know that all 3 of them have to be the same size. So since I don't know one, I'll call it x. And this one has to be the same, so it's x. And this one has to be the same, so it's x. Which leads me to my lovely little problem in which my 3 x's together have to add up to 180. If I divide both sides by 3, I get 60 degrees. And in an equilateral triangle, every angle is 60 degrees, always, always, always. That will never change. All 3 angles have to be 60 degrees, or you don't have an equilateral triangle. All right, so now let's use our special triangles to find a few more. I look at this one. I do know that this corner here is 90 degrees because I see the square. I also see that it's isosceles. So that means this one is 5x, then it means that one also has to be 5x. And so if I want to write an equation, I remember that all three add up to 90 or 180 degrees. So that would be my 5x plus my 5x plus my 90 equals 180 degrees. I'm going to combine my like terms. 5x plus 5x is 10x plus my 90 equals 180. Let's go ahead and add that in. We're going to subtract 90 from both sides, which means that 10x's, because those cancel out, are equal to 90. And then last step, divide both sides by 10. So x is going to be 9 in this case. Again, that's just the value of x. If I said how big are the angles, well, I'd say that one's 90, and this one is 5 times 9, which is 45. So this angle here is 45 degrees, and this angle up here is the same, 45 degrees. All right, last problem, here we go. Okay, this one we don't know, it's x. This one we do know, it's 34, but I can see that these two sides here are equal in length, which means that the angles across from it also have to be equal in size. Now, well, if this one's 34, it has to match this one. So this one is also going to be 34 degrees, which is now, because we have two of the three, we can solve for our missing x, or our missing angle. So let's start with all three have to add up to 180. So x plus 34 plus 34 equals 180. I'm going to combine like terms. So I'm going to add 34 plus 34. That's going to give me 68 equals 180. And now I'm going to solve my equation by subtracting 68 from both sides. That leaves me with x equals 112. And in this case, that is the value of x, but if I look up here, it's also the value of that angle. So the angle is 120 degrees. So that is how we use special triangles, scalene, isosceles, equilateral, and of course we can also name them by their angles: acute, obtuse, and right. Until next time, bye guys.